Let's begin with another topic how a DFA processes strings. This presentation will explore the fascinating world of deterministic finite automata, which is known as a DFA, explaining how they effectively process the strings. Introduction to Deterministic Finite Automata. A deterministic finite automata is a mathematical model of computation that recognizes patterns in strings of symbols. It is a finite state machine, meaning it has a finite number of states and transition between them. DFA are widely used in computer science, particularly in areas like test processing, compiler design, and network security. They are fundamental to understanding how computers recognize and process information. Components of DFA: its states, transitions, and accept states. In states represent different configuration of the DFA. Each states represent a unique stage in the processing of an input string. Transition Transitions define how the DFA moves between state based on the current input symbol. They are like pathways connecting states. Accept states indicates that the DFA has successfully recognized a valid string. They are marked with a double circle in a DFA diagram. Here you can see a perfect diagram of a DFA. So let's begin with the DFA processing mechanism. The first step is start state, second one is input symbol, third one is state transition, fourth one is repeat. In the first stage, start state, the DFA begins in the initial state ready to process the input string. At the second stage, input symbol, the DFA reads the first input symbol from the string. At the third stage, state transition, based on the input symbol, the DFA moves to a new state via transition. At the fourth and the last stage, it will repeat the criteria. This process repeats for each subsequent input symbol, transitioning the DFA through different states. Reading input symbols and transitioning between states. Input symbols. The DFA reads an input symbol from the string one character at a time. After reading the input symbol, transition will occur. The transition occurs from the DFA uses the current state and input symbol to determine the transition to the next state. State update. The DFA updates its current state to the new state dictated by the transition. Reaching the accept state and a string acceptance. Uh, to reach the string acceptance, first we need to begin with the processing and the accept state and the acceptance. At the first processing stage, the DFA continues processing the string, moving through states as it reads each input symbol. Accept state: if the DFA reaches an accept state after processing the entire string, it accepts the string. String acceptance: the string is considered valid if it leads the DFA to an accept state. So let's begin with examples of DFA in string processing. The first example is string A B A B B A B A B B. In this, DFA accepts the string is recognized as valid. And the second example is string A B B A A B B A. DFA rejects. The string does not lead the DFA to an accept state. Example 3: string A B A B A B A B. DFA accepts the string is recognized as valid. Uh, s- uh, let's start with the handling different input string lengths. The first step is string length, second one is input processing, third one is state transition. In string length, DFA are designed to handle strings of any length as long as the string follows the rules defined by the DFA. Input processing: the DFA processes each symbol in the string regardless of the total number of symbols. At the third stage, The DFA uses its state transition to process each symbol no matter how long the string is. So at the last, advantages and the limitations of DFA. First, we see the advantages: efficient and deterministic. DFAs are known for their speed and consistent behavior. Simple to implement, DFAs are relatively easy to design and code, making them practical for real world applications. Ideal for pattern matching, they excel at identifying specific patterns in strings. So let's start with limitations. Limited memory, DFAs can only store a finite amount of information about the past input, not suitable for complex languages. They struggle with complex languages that require unlimited memory or recursion. At the last, practical applications of DFAs: search engine, network security, compiler design. Search engines are those where DFAs are employed to match search terms and return relevant results. Network security, DFA are used to detect malicious traffic and protect networks from cyber attacks. Compiler design, DFAs play a crucial role in lexical analysis, breaking down code into meaningful units. Thank you.